Alright, so for the next couple of days we're going to be looking at factoring. And factoring is basically the reverse of the distributive property. So for instance, if you have something like, for example, 2x and then x plus 4, then when you distribute this, and we all know how to distribute, you distribute the 2x into both of these, okay, then you would end up with 2x squared plus 8x. Now, this is called distribution. What we're going to be looking at today is going to be the opposite. We're going to start with something like 2x squared plus 8x, and we're going to factor the 2x out, and we're going to be left with x plus 4. So going from this multiplication to just two terms here, that's distribution. But here, we took a 2x out of both terms. This is called factoring. Alright, in the first one, we put the 2x into both of the terms, multiplied. And the second one, we took the 2x out of both the terms. That's called factoring, where we took it out. This one, we multiplied by 2x to put it on the inside. This one, we divided by 2x to bring it to the outside. Alright, and that's what we're going to be looking at today, is how to factor, how to do that. Now, the gist of it is division, looking for the largest common or the greatest common divisor, or the greatest divisor that goes into both of them. Essentially, for example, 3x plus 3y, we know that 3 goes into 3x and 3 goes into 3y. So we can factor out the 3, and when we divide 3x by 3, we get x, and we divide 3y by 3, we get y. So distributing the greatest common factor out of this, or factoring a 3 out of this, which is the greatest common factor, the 3 comes to the outside, and what we're left with is x plus y. And you can very, very quickly check to make sure that this is true just by distributing back into the parentheses. 3 times x is 3x, 3 times y is 3y. Now, if we look at x squared minus x, you got to think about what x squared is. X squared is x times x. And x is just x. So what this really is x times x minus x. We can tell that a divisor of x squared is x, because x goes into x squared. And a divisor of x would also be x. So in this case, we can factor out an x. And if we factor out an x from x squared, all we're left with is an x. And if we factor out an x from minus x, we're left with a minus 1. Because negative x divided by x is negative 1. And then we can check this. X times x is x squared. X times negative 1 is negative x. For number 3, we need to check the factors of both of the numbers and the variable. The greatest common factor of 7 and 21 is 7. So we're going to factor out a 7 from both of those. But we also need to check the variable, x cubed and x. Well, the greatest common factor of those two is going to be x. X goes into x one time, and x goes into x cubed x squared times. So we would factor out a 7x. And then what we're left with, we need to divide by 7x to figure out what we're left with. 7 divided by 7 is 1. And x cubed divided by x is x squared. So when I factor out a 7x from 7x cubed, I'm left with x squared. For the next term, 21 divided by 7 is 3, and x divided by x is 1, so we don't have to write that. So the factored form would be 7x, parentheses, x squared minus 3. We could check this just by distributing. 7x times x squared is 7x cubed. 7x times minus 3 is negative 21x. We can do the same thing when we have multiple terms. 1, 2, 3 terms. We can factor out for all of them. So if we look at the coefficients, 2, 4, and 6, the largest factor of those is 2. If we look at the variables, y cubed, y squared, and y, the largest factor of those three are y. And then to figure out what we're left with, we just need to divide it out. So we're dividing each of these by 2y to figure out what we're left with. 2 divided by 2 is 1, y cubed divided by y is y squared, so the first term we're left with y squared. 4 divided by 2 is 2, and y squared divided by y is y. And then for the last term, 6 divided by 2 is 3, and y divided by y is 1, so we don't have to write that. So our factored form would be 2y, parentheses, y squared plus 2y plus 3. We could check this. 2y times y squared, 2y cubed. 2y times 2y, 4y squared. 2y times 3, 6y. For number 5, whenever your first term starts with a negative number, or it has a coefficient that's a negative, you always want to factor out a negative number. All right, we don't want this first term to be negative. So we want to factor out whatever we're factoring out, we make it negative. So in this one, I need to factor the coefficient, I need to factor the a's, and I need to factor the y's. So I have three things I need to factor. So first I'm going to look at the 3 and the 6. The greatest common factor of 3 and 6 is 3, but this negative sign means I'm going to factor out a negative 3. For the a's, a and a, the greatest common factor is a. And for the x and y are two different variables, so I can't really do anything about those. There's no greatest common factor for x and y. So what I'm going to factor out is negative 3a. So I'm going to divide both of these by negative 3a. So negative 3 divided by negative 3 is 1. A divided by a is 1. Those cancel. And all I'm left with is x for the first term. For the second term, 6 divided by 3, negative 3, is negative 2. A divided by a cancels, and the y is left over. So my factored form is negative 3a, parentheses, x minus 2y. And we can distribute to check this. Negative 3a times x, negative 3ax. Negative 3a times negative 2y is positive 6ay. Number 6, we don't have to factor the constants because this is the only one, the coefficients. This is the only one with a coefficient. The only thing we need to factor are the x's. So x squared and x squared, the greatest common factor of those would be x squared. But this starts with a negative. The first term is a negative, so I want to factor out a negative x squared. So I'm going to divide both of these by negative x squared to see what I'm left with. So negative x squared divided by negative x squared, that's just 1. Negative 3 divided by negative 1, so this is going to be plus because I have negative, negative. I have a negative divided by negative, which is going to be addition. I still have the 3, the x squareds cancel, and I still have the y. So it becomes negative x squared, parentheses, 1 plus 3y. And you can distribute this to make sure negative x squared times 1, negative x squared times 3y, negative 3x squared y. For number 7, I need to factor the x's, and I need to factor the y's. It looks like, and I need to keep in mind this is negative, so whatever I factor out is going to be negative. For the x's, I have x, x squared, and x. So the greatest common factor of those three is x. And then for the y's, I have y, and y squared. So the greatest common factor there would be y. I'm going to divide these by what I'm factoring out. So negative xy, and this is going to tell me what's left over. So everything here cancels, so I'm left with 1 there. This next term is going to be negative because it's a positive divided by a negative. The 6 is still there. X squared divided by x is just x, and then the y's cancel. So the next term is minus 6x. The next term, I have 2 negatives, so that's going to be addition. The 4 is still there. The x's cancel. Y squared divided by y is just y. So the last term is 4y. So the factored form would be negative xy, parentheses, 1 minus 6x plus 4y. It's all about finding the greatest common factor and then removing the greatest common factor. That's the first thing we need to look at. There's also another way that we can so this is called factoring out the greatest common factor. This typically occurs when every term has a greatest common factor that you can factor out. There's also something else which is called factoring the difference of 2 squares. And what this means is that this is a special type of factoring that we can do if we have 2 squares subtracted. So we have an x squared minus a y squared. Then this can factor into 2 distinct factors, 2 binomials, x plus y times x minus y. And we can see why that works because if we distribute, so we have x plus y and x minus y. If we distribute here, you remember how you distribute. You multiply the first one by both, you multiply the second one by both. Then what we would get is x times x, which is x squared, x times minus y, so that's minus xy, and then y times x, which is plus, so plus xy, and then y times negative y, which is negative y squared. And you can see that this minus xy and this positive xy, those would cancel. And what you would be left with is x squared minus y squared. So it turns out, if you have 2 squares being subtracted, you can factor it into this form as long as you know what the first square and the second square are. So let's look at what that looks like. And the key to this is writing the term as a square. So if we look at this one, x squared minus 4. Well, x squared is obvious. It's just x to the second power. So the x would just be x. Minus 4 is a square. It's actually 2 squared. Let me move this. It's actually 2 squared. So in this example, the x is x, and the y is 2. So this is the first square, x squared, and this is the second squared, 2 squared. So the factored form would be x plus y. X is x, and y is 2. So it would be x plus 2. And then the second one would be x minus 2. And this would be the factored form, x plus 2, x minus 2. This would be the factored form. You can check it by distributing x squared minus 2x plus 2x minus 4. The 2x and minus 2x would cancel. It would just be x squared minus 4, which is what we started with. So it helps to write it like this, as the squares, then you know what to write it as. So let's look at number 2. So number 2, 16x squared minus 1. So 16 x squared, that's just 4x squared, because 4 squared is 16 and x squared is x squared. Minus 1, so 1's also a perfect square, it's 1 squared. So here are the difference of squares. In this example, x would be 4x. So 4x is what's being squared for the first term, and then what's being squared for the second term is 1. So that would be y. So we'd have 4x plus 1 for the first one, for x plus y, and then 4x minus 1 for the second one. So this is the factored form, 4x plus 1 times 4x minus 1. And if you distribute it, you would be able to see you get back to 16x minus 1. Number 3 is a little bit trickier because of the fraction. So the way that we do the fraction is, let's just set it up. We want to know what the square is here and what the square is here. So the way that you do a fraction is we actually do the numerator, and you do this by taking square roots. If you haven't noticed, the square root of 16 was 4, and the square root of 4 was 2. So here, the square root of 1 is 1 on top, and then on the bottom, the square root of 25 is 5. So this would be 1 over 5, because 1 squared is 1, and 5 squared is 25. And then x, because x squared is x squared. So in this example, the x is 1/5 x. Over here, to get 4, the numerator would be 2, because 2 squared is 4, and the denominator would be 3, because 3 squared is 9. So my difference of squares, my x value would be 1/5 x, my y value would be 2/3. So the factored form would be 1/5 x plus 2 over 3 times 1/5 x minus 2 over 3. And if you factored this out, if you distributed, you would get back to 1 over 25x squared minus 4 over 9. For number 4, once again, it's just easiest to write it as a difference of squares. So something squared minus something squared. Well, this would just be x. X squared is x squared. For 16, that would be 4, negative 4. Nope. And actually, we have a problem here because x squared plus 16 is not a difference of squares. It's a sum of squares. It's x squared plus 16, and it's the sum of squares. And there's no way to make it a difference of squares. So this one, we can't actually do. This one's not going to work, so we can't do that one. We cannot use this difference of squares method for number 4 because there is no difference in squares. So we're going to have to just, can't do that one. We could call this prime. We could say that it can't be factored, but you wouldn't know this at this point because there are other ways to factor. This is just a special case factoring the difference of 2 squares. I know that this one is prime, so I'm going to write prime. Can't be factored. For number 5, you may look at this and say that maybe this one can't be factored as well because it's not a difference of squares, it's the sum of squares. However, it can actually be written as a difference of squares. If the 81 came first, you would see that it's different of squares. But also, it can be helpful to factor out the GCF first. All right, we learned in the previous examples that we can factor out a GCF. In this case, it starts with a negative. which means we want to factor out a negative. So we want to factor out a negative 1. So this becomes x squared minus 81. And now we can see that x squared minus 81 is a difference of squares when we factor out the negative. This is why it's important to factor out the negative here. Alright, let's see. This is a difference of squares now. Alright, if we write it as a difference of squares, we would see that this is x squared. X squared is x squared, and then 9 squared is 81. So this factors into x plus 9, x minus 9. However, don't forget the minus sign from the beginning. So we do need that on the outside. We do still need that on the outside, and this would be the factored form of the original problem. Negative x plus 9, x minus 9. Alright, so don't forget the minus sign from the original problem. Now you could do number 6 by simply doing it as it is right now, but typically we want the squared to come first. So we would rewrite this first, negative 9x squared plus 81. Just like the previous problem, it starts with a negative now. We could have done it like this without starting with a negative, but it's better form to put it like this. We also see that there's a GCF. The numbers 81 and 9 have a factor in common, 9. So I can factor out a 9 and make it negative because I don't want this to start with a negative. And this would be x squared minus 9. Right, because I factored out the negative 9, and negative 9 to the negative 9 is 81. And now, this right here is a difference of 2 squares. Squared, squared. To get x squared, we have x squared, and to get 9 squared, we have 3 squared. And you can figure that out just by taking the square roots. The square root of x is x, the square root of x squared is x, the square root of 9 is 3. So that means this factors into x plus 3, x minus 3. However, don't forget the minus 9 that's supposed to be in front. So I'm going to bring that over here, and this is my factored form of the original problem, 81 minus 9x squared. I get negative 9, x plus 3, x minus 3. And that's my factored form. Number 7. You might be saying, you can't, negative 50, so negative 50, let's see, squared minus squared. Negative 50, that's not a perfect square. That's correct. 50 is not a perfect square. You're correct. There is no number that squares perfectly to 50. However, you can still take the square root of 50. Okay, the square root of 50 is just the square root of 50. And the square root of x is just x. So taking the square root is an acceptable way to do this, and we could say that this is now a difference of squares, x squared minus square root of 50 squared. Square root of 50 squared is just 50. So this becomes x plus the square root of 50, x minus the square root of 50. Alright, I just want to point out all of these could be done by taking the square root. So like number 4, for example, squared, it's a difference of squares. The square root of x squared is just x, and the square root of 16 is 4. So you could have got this by just taking square roots as well. And it's absolutely necessary, number 7, to take square roots because 50 isn't a perfect square. So this would be the factored form: x plus square root 50, x minus square root 50. All right, and the worksheet for this is on Canvas. It's worksheet factoring GCF and x squared minus y squared, or difference of squares. You can check your answers just by using the distributive property.